Assalamu alaikum. Welcome to my channel Tech Talk with Shahid. Our today's topic is lapping length. Why we provide this lapping length, how we calculate, and how to select the location of lapping. First of all, we will discuss why we are providing this lapping length. Since this is the weakest point of any structural element, but we don't have any choice. We cannot avoid when we have long members. If the length of any structural element is more than the maximum available length of steel bars, so then we need to provide this lapping. Maximum length of reinforcement what we are getting is 40 feet or 12 meter, but sometime our structural member length is more than that, then we need to provide this lapping. That lap length we need to provide is to transfer the load from one bar to another bar. So it depends what dia bar you are using. If we are using 12 mm dia bars, it means that bar will take the less stresses, less forces. So it required less length to transfer one reinforcement forces to the another lapping reinforcement. So if we are using higher dia bar, so we need bigger length. So we will see first how we calculate that bar length. Suppose this is our one bar and it's another bar. So this lapping is called lapping length or splice length, or simply we are called lap length. The calculation process of lap length is almost same as we are calculating for development length. Almost same formulas are we are using, and when we go for thumb rule, so it will be same. To calculate the lap length, first we need to see where we are providing this lap length. Either this lap length we are providing in tension zone or compression zone of beam. Like this is our beam and this is our column. This is the neutral axis of beam. So this bottom portion is always in tension and upper portion is in compression. So when we are providing this lap length in our tension zone, so we need to be more careful, because when we have a reinforcement in tension zone, so we need a proper calculation, or we need to fulfill its minimum requirement. And when we need to provide that lap length in its compression zone, so it's a bit relaxing zone as compared to tension zone. For tension zone calculations, you can see this code requirement. This is the formula which we use for tension zone lap length calculation, but lap length should not be less than 300 mm in for tension zone. But when we are calculating lap length for compression zone, then again we need to use this formula as per ACI code, ACI 318 chapter number 12. Its length should not be less than 200 mm for compression. These are the two formulas what we are using for tension and compression lapping. But when we don't have enough time for calculations, then simply we are using thumb rules, which all over the world every structure engineer is using, which is 40 to 50D. This 50D is when we need to calculate tension zone lapping. then we need to consider this 50D. And when we are going to calculate lapping for compression zone, then it can be between 40 to 45D. So these are the thumb rules which simply we can follow for lapping length. For example, uh, for example, when we have when we need to calculate tension zone lap, and dia bar is supposed 20 mm, then lap length should not be less than 50 into 20,000 mm. When we are calculating lap length for compression zone, then it should not be less than 45 into 2900 mm. But as per common practice here again, for compression and tension, we are using same 50D to be on safer side. So we can say 1000 mm again. We can consider lapping for compression zone also. Now we will discuss how to select the location of this lap, that we will discuss here. We will draw here beam to learn how we select the location. I will show here one continuous beam for more clarity. This is our continuous beam. And our reinforcement is something like this. This is going up, and like we provide in last block, these are the development length. Okay, now it's our continuous beam. So now we need to select the location of lap length, means where we will provide and how we will provide. Like this is the tension zone of beam, and it's a compression zone. Okay, so as you know, our bending moment arrangement for continuous beam will be something like this. So from this bending moment diagram itself, we can see where we can provide our lap length for tension zone and compression zone. For bottom reinforcement, we should avoid this location because here bending moment is maximum. So we should provide lap somewhere here in this location. But when we will go for top steel, so our negative bending moment is maximum near the support, so we can provide lap length away from this. Means this is the location of lapping for top reinforcement, and these are the locations for bottom reinforcement. So we need to select this location something like this. We will discuss further lapping zone in detail in our next vlog. Now we will discuss about the arrangement of lapping. Suppose this is our beam cross section, longitudinal cross section. Here is our support. Like here is our column, here is our column, something like this. This is column, this is our column. So our reinforcement arrangement is something like this. Suppose we have 3 bars in cross section. Imagine these are the bottom reinforcement. If we show our cross section for beam, these are 3 bars, 3 we can say on top, and these are its neutral axis, and we cut our section from here. Our section 1 is here. So we are looking at this bottom reinforcement in top plan. So when we need to select our location for lapping, since it's a bottom reinforcement, as we discussed before, a bottom reinforcement lap should be above the spot or near the spot. So our lap length will be something here. But since this lap length location is the weakest point of any element, so we should avoid the continuity of lap arrangement. We should try alternative bar. Lap length location should not be matched with both side reinforcement to create the more continuity. So our alternative bar lap length should be something like this or something like this. We should avoid continuity of this lap length. So that bar length should be somewhere here or somewhere here. So like this arrangement we need to see to avoid the continuity of this lap. So in this way, if we manage in this way, so we can achieve the maximum strength of any structural element. Now we will see if we are providing that lap length in our column. This is our column, this footing. Suppose this is the dowel length, dowel bar length. So, and we need to provide lap here. We need to provide lap here, but alternative bar lap should be something like this. So we should avoid to keep all lap arrangements in same location. So this is the correct way. If we have same lap length, if suppose we have this lap length again on same location, so this is the wrong way, because all lap length are coming in same arrangement, and this is the weakest point of any structural element. Another thing, when we provide lapping, we should keep bar in same line, but when it comes near to the lapping location, we should bend it and insert it inside. So in this way we will try to achieve the maximum D length, because D length, it always affect the design of any structural element. If we reduce this, if we keep the length straight, then our member will come something like this, because we need to keep this inside. So in this way we are increasing here D distance, which is the wrong practice. We should keep clear cover as same as we are providing in bottom reinforcement, but when it come near to the lapping length, we should bend it inside. So this is the correct way. I hope our today's topic is informative for you guys. If you have any comment related to this discussion, please send your comment, and we will try to respond as soon as possible. If you learn anything from our videos, please like it, share it, and subscribe my channel. Thank you so much.